All right, future programmers, welcome. If you're getting ready for that AP Computer Science A exam, you already know arrays are a huge deal. But here's the thing, just knowing what they are isn't going to cut it. You have to be a pro at working with them. So today, we are diving deep into a super important skill, implementing array algorithms.
Okay, let's make this real for a second. Picture this, your music library has a million songs. How in the world do you find that one perfect track you're looking for? I mean, you can't just scroll forever, right? You need a strategy, a smart plan. And guess what? That's exactly what we're going to build today.
So I like to call this the digital haystack problem. You've got this massive collection of data, and finding that one specific piece, it's literally like searching for a needle in a haystack. Or think about it this way, you're looking for one book on a giant, totally disorganized bookshelf. What's your plan? You'd probably just start at one end and check every single title one by one, right? Well, that systematic process?
That's exactly what an algorithm is. See? It's not some scary, super complex idea. It's just a step-by-step plan for solving a problem. And let me tell you, in programming, having a solid plan, it's everything.
Okay, so to solve these haystack problems, we're going to need the right tools. Think of it like this. Our computer science toolbox is just filled with different algorithms, and each one is like a specialized tool designed for a very specific job.
Now, you're going to want to pay close attention here because this is a huge term for the AP exam. An array algorithm is, pretty simply, a set of instructions made specifically to work on data that's stored in an array. You can think of it like a recipe for finding, sorting, or even changing that data.
Now listen, algorithms do way more than just search. We use them for all sorts of things. We use them to sort data into order, to pop in new items, to delete old ones, or even to find the absolute smallest or largest value in a whole set. They are the real workhorses of programming for sure.
All right, enough theory, right? Let's get our hands dirty and actually write some Java. We're going to build the most fundamental, the most basic search algorithm out there, the linear search. This is basically the coding version of checking every single book on that shelf we were just talking about.
So here's our mission. Nice and simple. We're going to write a Java method that takes an array of integers and a target number, and it's going to tell us the exact index where that target is located. Okay, first up, the method signature. We'll start with public, and it's going to return an int that's going to be the index of our target. And what does it take in? Two things. An integer array we'll call ARR, and the integer target that we're looking for.
Next up, we have to visit every single element in the array, and for that, a for loop is our best friend. We'll start our little counter, I, at 0. Remember, array indices always start at 0. And we'll just keep on going as long as I is less than the array's length. And of course, we'll increment I each time to move to the next spot.
Okay, now we're at the heart of the search. Inside our loop, for every single element, we ask a simple question. Hey, does the value at the current spot, array of I, match our target? If the answer is yes, boom, we found it. We can stop everything right there and just return I, which is the index where we found our match.
But what if the target just isn't in the array? What happens then? Well, if we make it all the way through the entire loop and never find a match, this final line, and notice it's outside the loop, takes care of that. We just return -1. This is a super common trick in programming. It's a signal that means not found. Because, think about it, -1 can never be a real array index.
Okay, let's just step back from the code for a sec and recap the logic. This is the core idea, right? Start at the very beginning, check the item against your target. If it's a match, you're done. If not, move to the next one. And you just repeat that until you either find it or you run out of things to check. It's simple, it's logical, and you know what? It always works.
So knowing the logic, that's half the battle. But writing bug-free code, especially when you're under pressure, like during an exam, well, that's the other half. So let's talk about one of the most common traps you'll definitely want to avoid.
Okay, this is absolutely crucial, so look closely at that loop condition. On the left, you see the code uses I less than equals r.length. This, my friends, is the classic off by 1 error. Just remember, if an array has 5 elements, its indices are 0, 1, 2, 3, and 4. Its length is 5. So that code on the left is going to try to access R5, which doesn't exist. And what happens? Boom! Your program crashes with an error. The right way, the only way, is I less than r.length.
And I'm not just being dramatic here. This is seriously one of the most common bugs in all of programming.
Getting your loop boundaries right is going to save you from so many headaches and, maybe more importantly, from losing easy points on your exam.
Okay, let's start to wrap this up. So how can you take all this and really master arrays for that AP exam?
Here's your checklist for success. Number 1, really understand the logic, the why behind the code. Number 2, you've got to be able to implement that logic in Java. 3, practice tracing the code. That means stepping through it with some sample data, just like the computer would. And finally, number 4, learn to spot those common errors, like the off by 1, before they even happen. And really, this brings us to maybe the most important point of all. The AP exam, it's not a memorization test. It's about understanding the concepts so deeply that you can take them and apply them to solve new problems you've never seen before. Understanding the why, that is your real superpower here.
So you've done it. You've now got the linear search down. It's a reliable tool. It's a trusty hammer in your toolbox that always gets the job done. But I want to leave you with a question to chew on. Is it always the fastest way? What if that list of 1,000,000 songs was already sorted alphabetically? Do you think you could find a song much, much faster? Well, that's a topic for another day. Thanks for diving in with me.